through our liquids depot process and ultimately making jet fuel. But before we get into that, I wanted to take a step back and look at our previous webinar that we gave. What you see here is Port Townsend Paper, specifically Port Townsend Paper Company's site. And the process you see is kind of an overview of the process for our liquids depot. So, well, like I said last time, we bring in the woody biomass into our liquids depot, and then so we looked at the liquids depot and that process with the biomass, and then we took a zoomed out step back look and looked at the sugar market and the liquids depot, or the lignin market, and looked at the feasibility of our products. Today, we're going to be talking about the liquids depot in regards to the Port Townsend Paper site. You will see 3 potential site locations and how we're going to do system design for those 3 locations. We're going to weigh the pros and cons for each, and then we're going to take a qualitative standpoint as far as costs for each site. So with that, I'm going to pass it off to Destry, and she's going to go in depth into the liquids depot.
Thanks, Taylor. So we're going to get started today talking about the liquids depot. When we're going into our site analyses, we're going to break these up into 3 separate footprints. They might be grouped together or they might be grouped separately just based on the layout of the site. Our first footprint is for our chemical storage, which we project to take about 0.1 acres, where all of our chemicals will be stored, pretty straightforward. Our liquids depot, where the process actually happens, we think will take about half an acre, and our packaging and distribution footprint will be about 0.5 acres as well. And Taylor will go a little more into how that actually works when we get into our first site analysis. So we talked about this before. Our liquids depot is a very intensive process, but we've simplified it into these 4 steps and even further simplified it into its mild bisulfite pretreatment and its enzymatic hydrolysis. As previously discussed, we expect a water demand of about 2 million gallons of water a day, and we also expect to create about 60 new jobs. And an important thing to note as we start talking about the water and the chemicals needed is that these are, they have about an 80% or so recycling rate. So while we need this amount of water and a certain amount of chemicals to get started, they will be recycled throughout the system. So going further into our chemical process, for our calcium bisulfite, enzyme, and lime, those will be stored in our chemical storage facility, again, about 0.1 acres of space. And we have been doing research onto how much these chemicals cost, where you can buy them from, how much of each chemical needs to go in per batch. And there are still some variables that we need to address, but we are working on that, and we'll have those numbers for you sometime next semester, hopefully. Again, after our woody biomass goes through its mild bisulfite pretreatment, ends up as a pretreatment liquor, and then goes into its enzymatic hydrolysis, we end up with a sugar slurry and a residual solid product. Those will be stored in our packaging and distribution center, which is about half an acre of space. And all of the heat and steam generated in this process, most of it is recycled back into the system as an energy source. And once again, our water and chemicals are also recycled back through the system. Now to talk about our first site analysis, I'll hand it back to Taylor.
Okay, thank you, Destry. So what you see here is a Port Townsend paper site, as I mentioned earlier. The 3 blue regions that you see are the 3 potential site locations that we felt were the best opportunities for a liquids depot to be placed on Port Townsend's existing site. So the blue lines you see are site contours, and we're going to go more in depth for each site as far as how this affects the site, but I just wanted to give you a brief overview of what that looks like on a site scale, noticing that the center site is relatively level and flat, and the 2 northern sites have pretty extreme elevation changes. Also noted that each contour line is 20 feet apart. So now looking into the northeast site that you saw earlier, this site is about 7 acres. The proposed site is about 7 acres. Again, drawing on those contour lines that you saw earlier, has an average grading of about 20%. And so as you can see in our weaknesses, this would be difficult for large amounts of development because of the extreme elevation change, about 60 to 80 feet from the top to the bottom. So this would be propose a challenge if we were to locate a pilot plant on this location. So next I'm going to take you through our process flow, products in and products out, and how this operation works. The gray area you see here is the proposed paved area, which is about 6.5 acres. So looking at our actual facilities, the small building that you see here is we have the chemical storage, which flows into the liquids depot, and then from the liquids depot in our process flows into our processing and distribution. And so just to give you an idea, and as Destry mentioned earlier, that's about above an acre in size. And so next we're going to look at, from a utility standpoint, so the yellow object that you see is the existing electric substation on Port Townsend site. And that's the flow from the substation to our proposed site using existing telephone lines. Also, not seen is potable water and sewer from our site. Potable water is something that we definitely will be using for our site. But as we choose our potential site that we look more into, then we'll get more existing infrastructure and decide how we're going to tie into those lines that way. So next, we're going to look at product in and the chip pile. So the red line that you see is products in as far as biomass and the chemical products going into the chemical depot. So the trucks go in through the existing path of the Port Townsend paper site, which would be a weakness because it would be conflicting a little bit with our operations. To mitigate that, we decided to put a weigh station on our site to keep it separate from their traffic on the existing Port Townsend paper site. So when the biomass comes into the brown chip pile, the biomass will be transported then from the chip pile into the liquids depot, where it'll get processed, and then the green arrow you see here is from the liquids depot, we would produce a dry lignin and a sugar slurry, which would be a liquid. The dry lignin we propose would be stored in 2,000-pound tote bags, which would be stacked on pallets, too high in any arrangement that we see fit necessary. And then for our most desired product, our liquid sugar slurry, that would be stored in large liquid tanks, which could then be pumped into storage trucks, which is also a strength of our site as this flow exits out into the road. So it can either go out and on truck out, or it can be taken to a barge, which Port Townsend Paper has great access for. And so next we're going to look at wastewater. And so the yellow line that you see is the wastewater leaving the storage or liquid depot. As you can see, this would be a weakness for our site, for this site, because this would be an extensive construction process wiring this waste utility from a liquids depot to the stormwater. And then next, we're going to look at stormwater. So the green object you see is a bioinfiltration, which is something that we are very curious in looking into. So a bioinfiltration is basically taking the surface runoff from the impervious pavement on the site, as well as the roof runoff, and running it into an engineered green space, which is basically consists of specific soils and native plants that would filter the stormwater and act as a self-contained system that we wouldn't have to mess with. This is a bonus for us because our stormwater wouldn't be put back into Port Townsend Paper's existing stormwater, which would be a benefit for our site. However, this site is located currently on the Larry Scott Trail. So in order for this site to be feasible, we'd have to relocate this very popular trail from Port Townsend. The orange line that you see is a potential reroute using contours just to show that this could be a feasibility. Notice the buffer in between the Larry Scott Trail and the potential site. So all in all, the northeast site does have some potential for as far as process flow, but it does have some large negatives when talking about elevation changes and having to reroute that Larry Scott Trail. Next, I'm going to pass up to Cody, and he's going to talk to you about the northwestern site.
Thank you, Taylor. So let's take a step back and look at the northwest site. This site is located just north of Mill Road, but south of the Larry Scott Trail. Zooming in a little closer, you can see this site is about 10 acres, more or less, although we will not be completely utilizing all of that. The grading of the site is not quite as extreme as the northeast site. Again, with the 20-foot contours, it's only about a 50-foot elevation gain between the north and the south. Looking at where our pavement would go on the site, it's about 6 acres worth of impervious surface, and it's a great location just due to its proximity to Mill Road. Seeing what our buildings would look like on this site, Again, it's just over an acre of these 3 buildings right here, the liquids depot, the chemical storage, and the distribution building. We would also be utilizing the same electrical substation here with just a short run that would need to be added to bring electricity over to the buildings there. If we were to put a chip pile on the site, it would go about here, and the road would be a very easy access just due to its proximity to Mill Road. We'd also be adding a scale here just to weigh in and off the trucks, unloading the chips and the chemicals that are going into our process. The trucks leaving the distribution facility would have great access as well to Mill Road. Our wastewater would be, it's very close to the existing wastewater facility, however, it would need to go across Mill Road, and that would involve probably high construction costs just due to the trenching involved with that. However, a pro for our site is we have plenty of room for the same bio infiltration opportunity that the northeast site had. We'd have plenty of room to make a big enough bioswale that could handle all of the stormwater runoff of all the impervious surface of this location. So overall, this site is a little bit better than the northeast site just due to its a little bit shallower grading and a little bit more room for expansion and just building and ease. Also, the access to Mill Road is really good. However, it's not quite as good as the central site, which Casey is now going to talk about.
So the final site we're looking at is the grain field in between the wastewater treatment plant and the chipyard. Zooming in, it's about 10 acres and it's very flat. There's only a few feet of elevation changes. So the site appears ideal because very little site prep would be necessary, and it's very close to the existing infrastructure. So onto the schematic design, we would need about 4 acres of impervious surface shown here. Out of this, about 3 acres would be pavement and 1 acre would be the liquid depot facilities. For electricity, the substation is very close, which is a strength for us. And now adding inputs, the red path leading to the liquid depot represents chemical deliveries, and the longer red path represents biomass deliveries. A strength of this site is that for biomass, we could utilize the existing truck scale and biomass dump ramps. There are concerns whether the infrastructure could handle the increase in deliveries, but we're confident the projected 50 truckloads per day would not significantly slow current operations because that number is small in relation to the current truck deliveries to the mill. Also shown here is our location to store the biomass. It's about 1.5 acres, and currently there's wood chips stored there, so the highlighted brown area further to the south represents an area where we can move those wood chips. And the brown path is simply the path where the biomass would enter the liquid depot. Looking at the outputs, the green path to the north represents shipments via truck, and the path to the south leads to the port, representing shipments via barges. Barges would be good because they tend to be much cheaper than trucks, and minimizing trucks coming in and out of the mill is also a benefit as well. For the wastewater, it would simply be discharged into the existing wastewater treatment plant, this short distance. And finally, for stormwater, we have a few options. It could simply be discharged into the wastewater treatment plant. The mill currently discharges their stormwater. Their stormwater is treated in there as well as their wastewater. But we want to avoid any unnecessary inputs in there, so we could do a bioswale like the other 2 sites, which is shown here, including an overflow pipe. The soils here are rapidly draining, and Port Townsend only receives about 19 inches of precipitation per year because it's in the Olympic rain shadow. So the actual size of the bioswale will be pretty small. But even so, this might potentially be unappealing here because this central land is valuable. And one final technique we're looking into is using filters. Current research here at WSU has shown that you can filter stormwater by running it through raw wood crumbles. And this is an emerging and exciting technique because it'd be very cheap. So we'd like to further explore that, and tests have shown it to be very effective. So now that wraps up this site, and now to compare the 3 sites and conclude the presentation, I'll hand it off to Joey.
Thank you, Casey. So now that we kind of looked at the 3 sites, I'm going to take a look at the 3 sites compared in a qualitative scope. And when looking at the capital expenditures, we kind of broke it down into a couple different sections. I'm going to kind of quickly just briefly go through them. So we started with site preparation. This particular section kind of included expenditures that you'd have to capitalize in order to get the land up and running for its intended use. Things such as cut and filling, regrading, cutting down trees, and just kind of any of that kind of mobilization of dirt would also be included in there. We then moved down to any utility work. So, for example, the top two sites, or the two north sites, would have to be installed pre-grade, and they'd have to not really tie into anything necessarily very close. I'll touch that in a second. And there's trail rerouting that we included. This would involve anything that would have to move the Larry Scott Trail or make any improvements to it in order to create a buffer between the facility and the people walking on the trail. And we included things with kind of a chip modification or a chipyard modification, or in the two cases of the north sites, we included the idea of a conveyor system to utilize the existing chipyard and move the chips up to those particular sites. So with that in mind, we're going to move on to the two north sites. We know that the northeast site has higher elevation changes, as well as it's a further distance from both the substation and the wastewater treatment facility. So right off the bat, if we put colors to it, with the red being a relatively high expenditure, the green being a relatively low expenditure, and the yellow being kind of in between in a qualitative standpoint, we see that the site preparation and utility installation would be more than that of the northwest site, particularly because of distances and elevation changes. I also put the trail rerouting in red because for the northeast site, we know that we'd have to full-on move the trail and in order to create a buffer zone and make any improvements to make it beneficial to actually move that. I put in green on the northwest site just because, as you saw earlier with Cody, that there may be a possibility of a small buffer zone that might be enough in order to not actually move the trail and keep distance away from the facility. With the conveyor chipyard colors, I associated a high expenditure to the northeast site, again, particularly because of distance. Because it's so much further from the existing chipyard, the conveyor system would be much longer than that of the northwest yard. So with those two in mind, we're going to also look at the central site. Associating colors, first we're going to compare it to the northwest site, particularly because out of the two north sites, it looks a little bit more promising in its proximity to the substation and the wastewater. And so if we color stamp it like we did with the first two, we see that there's much more green here on the central site. That's mainly because, like we've discussed, the site preparation be relatively minimal compared to the other two because of the relatively flat area. And utility rerouting or installation seems to be less because of the proximity to both the substation and the wastewater treatment being adjacent to it. With the chipyard modification, we had a little fun with that one, just with the idea because we're going to hopefully use the existing chipyard. And so that wouldn't, you didn't have to incur very many extra expenditures. You might have to install maybe another truck dump, but compared to the other two, we have to put a whole new scale and a truck dump or two. It would be much more for the northwest side. So bringing all three back up together, you see that on the far side we have mainly red, middle we have yellows and one green, and on this close side we have a lot of green. And so from our standpoint overall, we believe that the central site looks to be the most promising out of all three for a pilot facility. But yet again, I just want to say this is a qualitative view from a capital expenditure standpoint. So looking forward to next semester, we're going to be doing more design on the central site. We want to look at grading and site development, some more in-depth capital expenditure analysis and operating expenditure analysis, as well as look at the utility ties and wastewater ties. Something else that we're also very excited to look into is potentially taking the stormwater runoff from our facility and Port Townsend Paper Company's facility and put that through other filtration processes and other methods as opposed to just putting it into the wastewater treatment. So with all that being said, on behalf of my team, I'd like to thank you for tuning in, and we strongly encourage you to look at us next semester and see us dive deeper into the nitty-gritty details of our project. So thank you very much.